Hey, Wagwan, it's Mr. Garfield here, and we're going to be looking at a question in Cape Pure Mathematics Unit 1, Module 2. All right, that is coordinate geometry, trigonometry, and vectors. Okay, so now we'll be looking at how to prove another trigonometric identity. All right, as a matter of fact, we have two trigonometric identities here. Okay, now this is not a past paper question. However, I was the one who created this question for you because this is a question that can show up in the examination. All right. So part one says you are to prove that the cotangent of A plus B is equal to cot A times cot B minus 1 over cot A plus cot B. And part two says, hence prove that the cot of A plus B plus C is equal to that on the right-hand side. Okay, now let us get into the question. Let's do part one here. All right, so part one, proof. Let's put in a proof. There's part one, proof. Okay, so we're given the cot of A plus B is equal to the cot of A times the cot of B minus 1 over the cot of A plus the cot of B. Now what I'm going to do is to start off with the right-hand side of the equation. All right, so I'm going to say that the right-hand side is equal to cot A times cot B minus 1, all right? And I'm going to divide that. I'm going to divide that here by cot A plus cot B, all right? Now you should know that the cot of any angle, let's call it theta, is equal to what? The cosine of the angle over the sine of that angle, all right? So that's something that you should know. Basic trigonometric identity there. So with that being said, I'm going to rewrite cot A, cot B here as what? So I'm going to write this now as cot A, all right? Cot A is going to be written as the cos of A over the sine of A, all right? That's cos A over the sine of A. But remember, I'm multiplying by the cot of B, which is going to be the cos of B over the sine of B. All right, so I'm multiplying that. So I will have that there. Okay. And then remember, we have the minus 1. All right, we have our minus 1 there. And I'm dividing all of that. I'm dividing all of that now by the cot of A, which we know is cos A over the sine of A. Okay. Plus cot B, which we know is the cos of B over the sine of B. Okay. That is what we have there. So let me just draw the line here for you. All right, so cos A divided by sine A there. And we have cos B divided by sine B there. Okay. This is now going to be equal to, now I want to change this 1 now. All right, I want to change this minus 1 here. So we remember that in the numerator up here now, we want to have the same denominator. So I have the sine of A times the sine of B here. So I'm going to rewrite 1 as the sine of A times the sine of B divided by the sine of A times the sine of B. All right, let's do that. So I'm going to have the cos of A times the cos of B. All right, and I'm dividing that. I'm dividing that by the sine of A times the sine of B. All right, minus, I'm now going to rewrite 1 in terms of the denominator. So I'm going to write it as the sine of A times the sine of B. divided by the sine of A times the sine of B. Right? I'm not changing anything because that will still give us 1, right? And I can now subtract because my denominators are the same. Okay? So let us now draw our line here. All right, because remember that we're dividing all of this as well by the cos of A, the cos of A over the sine of A plus the cos of B over the sine of B. All right, now I want the same denominator here. So my denominator, all right, or my LCM is going to be the sine of A times the sine of B, right? So in my numerator, what I will have is the cos of A, all right? I will have the cos of A multiplied by what? I will have the sine of B, okay? And I'm gonna have my plus. Then my other term is going to be the cos of B multiplied by the sine of A, okay? So I hope you follow that. We're simply adding two fractions. All right, good. Just now continue. Let me just scroll down a bit here so that we have more space. Good. So this is now equal to, I can combine the numerators here. So I can now say that this is equal to the cos of A cos B minus sine A sine B. All right. And I'm dividing that. All right. I'm dividing that by the sine of A times the sine of B. That is my denominator there. Okay. And then now I have all of this divided by the cos of A times the sine of B, all right, plus the cos of B times the sine of A. And I'm dividing that, okay, I'm dividing that now by the sine of A times the sine of B. So what do I have now? I have a fraction here divided by another fraction here, all right? So if I'm dividing two fractions, it means that I will have to multiply by the reciprocal of the second fraction, right? The fraction there in the denominator. So I can now say that this is going to be equal to the cos of A, all right? So cos A, cos B minus sine A, sine B, all right, divided by the sine of A, sine of B, multiplied by, I'm going to take the reciprocal of the denominator here, okay? So I will get the sine of A times the sine of B in the numerator, and my denominator will be cos A sine B plus cos B sine A, okay? I hope that was clear enough for you. So let's draw lines here to show that we are dividing. Okay, good. Now clearly you see that we have the sine of A times the sine of B here, and we have the same thing here, right? So it means that those two terms can be cancelled out, okay? So what I'm left with is what? I'm going to have the cos of A times cos B minus sine A sine B, all right? And I'm dividing that by cos A sine B, okay, plus cos B times the sine of A, all right? That is what we have. Let me just put the line here to show that we are dividing. Okay, so we're dividing that. Good. So let us now continue. let me scroll down here. Okay, now let's look at the numerator. In the numerator, I have the cos of A times cos B minus sine A sine B. Do you know any identity for that? Well, you should recognize that the expansion of that is actually our compound angle formula, right? So the expansion of cos A plus B is our numerator there, right? And that is our compound angle formula that you should remember. In the denominator, we have cos A sine B plus cos B sine A. Do you know any identity for that one? Well, you should recognize that it is the same as the sine of A plus B, right? If you expand the sine of A plus B, you will get that in the denominator, okay? Now, what do we have here? We have the cos of A plus B over the sine of A plus B. And we know that the cos of any angle over the sine of the same angle can be represented as the cotangent of the angle, right? A plus B is the angle, okay? And the cot of A plus B is what we actually have on our left-hand side of the identity, all right? So we can now say that the right-hand side is equal to the left-hand side, all right? So it means that we have now proven the first part of the question, okay? So we are finished with the first part. Yes, so we are finished with the first part of the question. Now we can move on to part 2, which says, hence prove that the cot of A plus B plus C is equal to that on the right-hand side. All right? Now, let us notice this word here. This word says hence, right? Normally, when a question says hence, it means that we need to use something from the previous question in order to do this question, okay? So it means that I will have to use what I have proved previously, which is the cot of A plus B, all right, in order to prove the cot of A plus B plus C, okay? That is what we have to do here. So let's just do part 2 of the proof here. All right, so I'm going to write it down here. So part 2, proof. All right, so based on what we have proven previously, all right, we can say that the cut, what we basically prove is that the cut of P plus Q is equal to cut P times cut Q minus 1 divided by cut P plus cut Q. All right, I'm just using P and Q as the angles, okay? Because I don't want to confuse when I'm doing this part of the proof, okay? Because I really wanted to see what I'm actually doing. So I'm using different letters, okay? But it's the same thing, all right? So in order to get A plus B, remember here, so, all right, right here, I want to have A plus B plus C, all right? Remember that. That's what I want. So what I'm going to do now is to say I'm going to say let P be equal to A plus B, and I'm going to let Q be equal to C, okay? So if I do that now, what will I get? I will get the cut of P, which I know is A plus B, plus Q, which I know I'm replacing as C, all right? And that is actually what I have in the question as my left-hand side, the cut of A plus B plus C, okay? Good. So let me scroll down a bit here, all right? So let us now continue, because remember we're replacing P as A plus B and Q as C. So in my fraction now, I'm going to have the cut of P, all right? I'm going to have the cut of P here, which I know I'm replacing as A plus B, multiplied by the cut of Q, which I know I'm replacing as C, okay? Minus 1, right? Minus 1, and I'm dividing all of this now. I'm dividing all of that now by the cut of P. I know I'm replacing P as A plus B, plus the cut of Q, which is cut C, right? Replacing Q as C. Good. That is what I have. Now I need to prove that this is equal to the right-hand side, all right? That is in the question. So let us now see what we can do here. What is the cut of A plus B? We already know that, right? We were given that in the question. That's what we just proved previously. So the cut of A plus B, we know, is the cut of A times the cut of B minus 1 divided by the cut of A plus the cut of B. Okay? That's what we have there. Good. And remember, we still have our minus 1. And we're now dividing all of this now in the numerator. All right, we're dividing all of that by the cut of A plus B plus the cut of C. And remember now, we know that the cut of A plus B is the cut of A times the cut of B minus 1 divided by the cut of A plus the cut of B. Okay? That's what we have there in the denominator. Plus the cut of C. Okay? So all I need to do now is just add the two fractions here in the numerator and in the denominator. All right? So let's just do that. Let me just scroll down a bit here. Okay. So what we're going to have now is I'm going to replace the 1 in terms of the denominator, right? So I'm going to replace the 1 as cut A plus cut B over cut A plus cut B. Okay? So I'm going to have the cut of A times the cut of B minus 1 divided by cut A plus cut B, and I'm replacing the 1 as cut A plus cut B divided by cut A plus cut B, right? Not changing anything, but remember I'm adding the fraction, so I need the same denominators. Okay, let's draw another line here. All right, and I'm dividing all of that as well. So all of that in the numerator. Okay, so that's a bit lean. Let me try this again. Okay, good, much better. So in the denominator now, I'm going to take cut A plus cut B as my LCM. All right, cut A plus cut B is my LCM. And if I do that now in the numerator, I will obtain cut A, cut B minus 1 plus the cut of C multiplied by the cut of A plus the cut of B. Okay? Yes. So that is what I will have. So let me just write our line here to show that we are dividing. Okay? Excellent. Let's now continue. All right, so I'm going to simplify further. So this is now going to be equal to, I have the cut of A plus the cut of B in the denominator, and I'm subtracting now. All right, so I'm subtracting, so I will have the cut of A times the cut of B minus 1 minus, I'm subtracting now, right? So remember in my numerator here, let me write it for you. in my numerator here, I have 2 terms, correct? So it means that I need to put my brackets. Okay, cut A plus cut B. Okay, cut A plus cut B. Now, if I should expand the brackets now, what will I have? This negative here will affect each term inside the brackets, right? So let me just erase that and write what we would actually get here. Okay, I just wanted you to see that we're actually subtracting and we would have to distribute the negative inside. So if I'm subtracting now, I will get negative cut A, all right, negative cut B. That is what I will obtain. Okay, and I will put the division sign here. All right, I'm going to put my line to show that I'm dividing. And remember now that we're dividing all of this as well. Okay, all of that. Now let us simplify the numerator here. We will have cut A, cut B, minus 1 plus. I'm now going to distribute the cut C. All right, I'm now going to distribute this cut C here inside the brackets here. All right, so it means that I will have a what? I will have a cut A multiplied by a cut C, okay? Plus, I will have a cut B multiplied by a cut C, okay? And remember now in my denominator here is the cut of A plus the cut of B. Excellent. Now, remember, I'm dividing a fraction by a fraction, right? I'm dividing this fraction by this fraction here, okay? So if I'm dividing 2 fractions, it means that I will have to multiply by the reciprocal of the second fraction. So I can now say that this is going to be equal to, I'm now going to have cut A, cut B, minus 1, all right, minus 1. Yes, so cut A times cut B minus 1 minus the cut of A minus the cut of B, right? And I'm dividing that. Remember now I'm dividing that by cut A plus cut B. Yes, guys, so I will be going back to this step here because I recognized that I actually made an error, all right? Because remember now, let me erase the negative one here. Remember now that we had the cut of C on the outside, right? So I had missed that term. So we are multiplying that by the cut of C, all right? And I'm subtracting 1, okay? So we're going back here, right? Because I actually made that error. Okay, so I apologize for that. Just now continue from here. Okay, so I will say that this is going to be equal to, I'm now going to multiply the cut C by everything in the numerator. Okay, so if I do that now, I will get cut A times the cut of B multiplied by cut C. Okay, and cut C multiplied by negative 1 will give me negative cut C. Okay, and I'm dividing that. I am dividing that by cut A plus cut B, right? So cut A plus cut B. Okay, I'm going to rewrite the one now in one step, right? We know that this is going to be the cut of A plus the cut of B divided by the cut of A plus the cut of B, right? It's just rewriting the 1 there so that I can subtract the fractions there. All right, and I'm dividing all of this now. I'm dividing all of that. And what I'm going to do is to write my LCM here, which is cot A plus cot B. So in my numerator, I will get cot A times cot B minus 1 plus cot C multiplied by the cot of A plus the cot of B. All right? So that is what we'll have in the denominator here. Good. So let me just simplify the numerator here. Okay, let me scroll down a bit. This is now going to be equal to cot A, cot B, cot C minus what? Minus cot C, and I'm subtracting the 2 terms here, right? I'm subtracting those 2. So it means that I will have minus cot A minus cot B, right? That is what I will have. And I'm going to divide now. I'm going to divide that by cot A plus cot B. That's my LCM. And I'm dividing all of that. Okay. I'm dividing all of that by cot A, cot B minus 1. Okay. Plus, I'm going to now distribute the cot C by each term inside the bracket. All right. So I'm multiplying the cot C and distributing it inside. I will get what? I will get the cot of A times cot C, right? Plus cot B times cot C. Okay? And remember now I have my LCM there. So I'm dividing this by cot A plus cot B. Very good. Things are now looking good. And remember, I have a fraction here divided by another fraction here. So it means that I will have to multiply by the reciprocal of the denominator, right? Multiply by the reciprocal of the second fraction. So what I will now get is what? I will now get cot A, cot B, cot C, okay, minus cot A. I'm just going to put the minus cot A first, then the minus cot B second, and I'm going to put the minus cot C last, okay? So we're not changing anything, just rearranging the terms there. And I'm dividing this by cot A plus cot B. All right, that's my first fraction. And I'm multiplying that. Let me just scroll over a bit. And I'm multiplying that by the cot of A plus the cot of B. Right, that's my numerator when I reciprocate the second fraction. And in my denominator, I'm going to have the cot of A times the cot of B, right, minus 1 plus cot A times cot C plus cot B cot C. All right, that's what I have. So that is what I have there. Good. Now you recognize that I have cot A plus cot B right here. And I also have the same thing here. Okay, so those two terms will be canceled out. So what am I left with now? What am I left with? Well, I'm actually left with cot A, cot B, cot C minus cot A minus cot B minus cot C. All right, that's what I have in my numerator. And I'm dividing that. I'm going to now divide that by cot A, cot B minus 1 plus, well, let me put the minus 1 last. Okay, I'm going to put the minus 1 last. So I'm going to have cot A, cot B, okay, plus cot B, cot C. All right, so let me just scroll over a bit. So I'm going to have the cot B, cot C, just rearranging the terms here, basically, right? And then I'm going to have cot A times cot C, and then I'm going to put the minus 1 last. Okay, now if you look in the question here, all right, that is what we actually have on our right hand side of the equation, right? That is what we have. So what can I do now? I can now say that this is equal to the right hand side, all right? So remember I had the left hand side over here, okay? So I can say the left hand side is equal to the right hand side, okay? And we have now proven that identity, okay? And we have now proven both identities. This was a very good practice for you, okay? And I hope that it was very helpful, okay? I chose to do this question because I remember when students were doing the 2016 paper and CXC had the tangent of A plus B plus C, right? And that gave a lot of students a lot of difficulty. So I wanted to do something similar, okay? A similar question to that and go through it, okay? So I hope it was helpful. If it was, please ensure to like up the video, right? And you can also comment down below, okay? And share this video with your friends as well. I am Mr. Garth Reed, Student Ambassador for the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.